Hello, and welcome to an educational video on merge sort. No prior knowledge is required for this video, and we hope after watching you have learned a lesson on a technique that can be useful to you in the future. Merge sort is a form of an algorithm, which in short is a way of solving a problem. Merge sort solves the problems of sorting values from smallest to largest. Now, how exactly does merge sort work, and what makes it more efficient in comparison to other ways of sorting? Merge sort works by merging sorted smaller lists into lists 2 times the size of the current smaller sublists. So lists of size 1 merge into size 2, lists of size 2 into lists of size 4, and so on for the whole list. By breaking down the bigger problem into smaller pieces, it makes it easier by solving the smaller problems that can be combined into a bigger solution. Merge sort can be useful in sorting random lists of numbers, or as displayed later in this video, the different heights of basketball players. To give you a better idea of this overview, we are first going to look at a smaller problem of sorting 4 numbers randomly organized, in this case the numbers 4, 1, 3, and 2. The first step of merge sort is to break down this list into its smallest pieces. In this case, we can break down the original list into 2 smaller sublists of the elements 4 and 1 and 3 and 2. We can then break these lists down to compare individual elements. Using merge sort, we will start with the first or leftmost subset, which in this case would be the 4 and 1. We then know 1 is less than 4 and should be moved into the leftmost spot on this list, which represents the smallest value in the list. We then move 4 to the rightmost spot, which represents the largest. These values are now sorted. And now we could take a look at the next subsort, the 3 and 2. Because 2 is less than 3, we move it to the first position or leftmost position, and the 3 is moved to the last position. We now have 2 subsorted lists that we want to sort into a list of all 4 values. To accomplish this, we compare the leftmost or first elements in each sublist, in this case the 1 and the 2. As the 1 is less than the 2, we move the 1 into the leftmost place. We then compare the 2 leftmost elements again, in this case the 4 and the 2. As the 2 is less than the 4, we move the 2 to the leftmost place available in the list. We will then compare the 2 remaining numbers, 4 and 3. As 3 is less than 4, we move the 3 to the leftmost place available and are left remaining with just the 4. As there is nothing left to compare the 4 to, we move the 4 into the available place. And using merge sort, we now have a sorted list. This is just a small example. We will next use a more interactive example of sorting the heights of 8 different basketball players whose heights range from 6 foot to 6 foot 8. As you can see, there is a variety of heights between the 8 players. Merge sort presents an efficient solution to sort these players from smallest to largest based on their heights. We will now compare the heights of the first 2 players, who will separate themselves by stepping up and forming a new sublist from the group. The 2 players will then be sorted, moving the shorter player to the left, representing the smallest value in the group. We can then compare the heights of the next 2 players against each other when they move up from the group. They will be sorted by moving the shorter player to the left and the taller player to the right. We will then compare the next subgroup, where we will once again move the shorter player to the left and taller player to the right. We can then compare the last subgroup, who will sort in the same exact way as the previous groups. We now have 4 sorted subgroups which we would like to combine into 2. We can do this by creating 2 subgroups of 4 players each. We will start with the subgroup on the left. Because this group of 4 players contains 2 groups already sorted, we can compare each of the leftmost players first. As the player on the right is shorter, he will move to the leftmost position. As the player in the left subgroup was taller, he must now be compared to the remaining player in the right subgroup. As the player in the remaining right subgroup steps up and is taller, they are now sorted in order. The remaining individual from behind in the left subgroup must now be compared to the most right individual in the new subgroup. As he is taller than this individual, he will take his place in the most right position. The subgroup on the left is now sorted. The subgroup on the right must now be sorted. This group is also made up of 2 subgroups who have already been sorted. The 2 leftmost players of each subgroup will then step up. Because the player on the left is shorter, he will remain in place in the leftmost position. The player from the right group who has already stepped up will then be compared to the remaining player in the left subgroup. Because the player from the left subgroup is taller, he will move to the most right position. The remaining player from the right subgroup will then be compared to the most right player in the new subgroup. Because the player from the right subgroup is smaller, he will move to the left of the rightmost player in this subgroup. We are now down to two sorted subgroups that we would like to form into one large sorted group. To begin, like we have throughout this video, the leftmost player will step up first. Because the player on the right is shorter, he will be moved to the leftmost position. As the player from the left subgroup was taller, he will remain in place to be compared to the next player from the right subgroup. As the player from the right subgroup is taller, he will remain in place to be compared to the next player from the left subgroup. As the right player is taller than the next player in the left subgroup, he will remain in place to be compared to the next player in the left subgroup. As the player from the left subgroup steps up and is taller, the player from the right subgroup moves to the leftmost position. The next player in the right subgroup then steps up to be compared to the previous player. As the previous player is shorter, he remains in place. The last player in the left subgroup then moves up to be compared to the rightmost player in the new subgroup. He is taller and therefore moves to the rightmost position. The last and tallest player takes his place in the rightmost position, and everyone is happy. Merge sort allowed us to take this group of 8 unorganized basketball players and arrange them in height order from smallest to largest. We first did this by organizing 4 sorted subgroups with a size of 2 players each. We then formed 2 sorted sublists of 4 players each. We then used these 2 groups to form one large sorted group with each player arranged from shortest to tallest. We would like to thank you for watching and hope next time you have to sort values you think of merge sort.